Okay, so we did one-step equations earlier in the course. Now we're doing basically, these are sometimes called two-step equations. We want to get the letter A by itself, but there's a 2 next to it, and there's also a plus 8 on the left side of the equation over here. So we want to get rid of that plus 8. So the opposite of adding is subtracting. So we'll subtract 8 from both sides. And now negative 28 subtracted by 8. Just be careful with your negative sign there. You start on negative 28, and if you subtract, you should be getting smaller, right? And so you're going further back in the negatives. So it's like you're adding those digits and sticking a negative sign on. Negative 28 minus 8 makes negative 36. And now we got to get A by itself. That's 2 times A. So I'm going to divide 2 to both sides. So I get A is negative 18. Okay, and then over here, trying to get the letter N by itself, I'm going to add 6 to both sides to start off. And in case you're wondering, back over here, you could have divided everything by 2. You just have to make sure you divide 8 by 2 and 28 by 2. Over here, you could start by dividing everything by 8, but that's going to give you a fraction, and most of the time, we like to avoid fractions, right? So we got to get rid of this minus 6, so we're going to add 6 to both sides to make it cancel out. And now negative 62 plus 6, think about the number line. Here's negative 62. If we're adding 6, that means we're going up, right? So we should be going in this direction on the number line. So negative 62, the digits are shrinking. Shrinks down to negative 54. And now that's 8 times n equals negative 54. So we've got to divide both sides by 8. So we got 54 divided by 8. We just want to remember that's negative 8. Oh, so that's actually going to be a fraction. Let's leave it like that. Just simplify our fraction. You divide the top and the bottom by 2, you get negative 27 over 4. And I think that's as simple as we can go. So there's our solution for that one. Not so pretty, right? It's negative. If we want to check ourselves, we've got to plug it back in for n. So multiply that to 8. Oh, I lost it already. It's a negative times 8 minus 6 makes, I did something wrong here. 62 minus, oh boy, so I had a good thing I checked my work, huh, because it's the minus 54 here. I did that arithmetic wrong. I think I plugged in 8 in the calculator on accident. Negative 62 plus 6 is not negative 54, it's negative 56. So that changes everything. Doesn't change everything. It changes the last answer here. Divide both sides by, divide everything by 8, so this is a negative 56. Divide by 8. So we get negative 7 for our final answer. Let's check our work to see if it works. So we got a negative 7. If we plug that back in for n, we're multiplying it to 8. Then subtract 6, makes negative 62, so it checks out. So it pays to check your work, huh? So over here to get p by itself, my first step is to add 9 to both sides. So we get negative 12p equals 9 plus 9 makes 18. And then to finish getting p by itself, I need to get rid of that negative 12. So since it was multiplying to p, I got to divide both sides by negative 12. So we get negative 18 over 12, which is a fraction that can simplify. Divide the top and the bottom by 6. Negative 3/2. And if we're right, we should be able to plug in 1.5, which is negative 3/2 as a decimal. Multiply the negative 12, subtracted by 9, checks out. Okay, so that's 3 examples of solving equations with constants on both sides.